All right, for the Go portion of the Unit 4 Lesson 2 practice, we're starting off with finding domain and range for each function graph below, and we are using interval notation when we write our answer. So remember, domain is all of the x values for which our function exists, and the range is the set of y values that our function attains over its domain. So in number 16, if I'm just looking at the x-axis, and sometimes just drawing on this helps me, I see on the left my function starts over here where x is -5, and my function stops right here where x is 4. And I also notice that both of the ends of the function are what we call closed circles. So my domain starts at -5 and includes all the real numbers up to where x is +4. So again, when I'm looking at the domain, I'm really looking at the x-axis as my number line. And this would be the same as saying all the values for x that are greater than or equal to -5 but less than or equal to 4. But when it says use interval notation, this is the interval notation that we mean. All right, so the range of values, well, it's a very similar concept, but we said the range is what the function attains as far as y values go. So our minimum y value is -2, and our maximum y value that the function attains is, well, 1, 2, 3, +3. So our range begins at -2 and includes -2 and continues all the way to where y is +3. And again, you could write it like that, but that would be inequality notation, not interval notation. All right, number 17, similar, but I notice here we have an open circle. So we need to be careful that we exclude that x value from the domain. I'm going to zoom in because I'm not wearing my glasses as I'm filming this. So if I look, my function begins just before, so like if this is -10, this would be -8. So my function begins at -8, but my domain does not include -8. So that's when we use a parenthesis. Then my domain continues all the way over to where x is equal to +9, and we include 9. So we use a bracket. Again, it's not interval notation, but I think it's good to remember that this is how we could express that as an inequality. All right, for the range, again, if I look, my minimum value, well, the function goes through -4, but again, that open circle is telling us that that function doesn't actually attain that -4. So for my range, just like in the domain, I will exclude -4 from my range of values. And then if I look at the top, or like the greatest value my function takes on, it takes on the value of +4, and I want to include that. Again, we could, it's not incorrect to write this with an inequality, it's just not interval notation. So I could see that this function takes on every value on the y-axis from but excluding -4 up to and including +4, and that happens, it looks like right about there. We said the minimum's right about there at x equals -8. Okay, number 18. Ooh, 18 and 19 seem easier to me, at least. All right, so for our domain, I'll speed this up a little. We start at 1, we include the 1. We go out to 10, 11, 12. We include the 12. So our domain is from 1 to 12. That is where on the x-axis our function exists. For our range, I notice the minimum value is -4, and the maximum value the function takes on is, let's see, 5, 6, 7, 8. And the function includes every y value, or attains, rather, every y value between -4 and 8. So again, we use interval notation to show that. All right, and number 19, the domain, again, every x value we take on, our domain starts at 0 and stops at 1, 2, 3. So the domain of this little function is just from 0 to 3. And the range, well, the minimum value is 0. So now we're looking at the y-axis. The minimum is 0. The maximum is 7. So our range is from 0 to 7. All right, we're almost done on this last side. For each of the inequalities, they should really have you do this first before those domain and range questions, because it would help us writing the notation. For each of the inequalities, graph the values being described on the number lines. So you don't have to put a bunch of numbers on here. What I would want to see is, for this first one, for example, to show x is less than 6, I'm just going to put the number 6 on my number line. And since x is less than 6, that means that x does not ever equal 6. So that's where I'm going to use an open circle. So we use open circles when I have the less than or the greater than symbol. We use closed circles when we have the greater than or equal to, less than or equal to. I said those opposite. Kind of looks like an owl if we give it a smiley face there. Okay, so I digress. So we're going to use an open circle on the 6, and then I want to shade in the direction of values that are less than 6. So again, you don't have to put any other numbers on your number line, but it helps me to maybe think about where 0 would be. Would 0 be to the left or the right of the 6? Well, it would be to the left. So when I shade, I want to shade in the direction of values less than 6, which would be in the direction of 0, since 0 is less than 6. And what I have there in blue is our answer. That's what we're looking for. All right, 21, same idea. I'm just going to put a nice -9 on my number line. If it helps, I could remember that 0 is going to be to the right of -9. So x is greater than or equal to -9. So I want to put a closed circle to show that x could equal -9. And then I want to shade in the direction that is greater than -9. And if you ever get your symbols mixed up, because in number 22, I see how this could happen. I know this is a little elementary school, but it always helps me to think of the inequality symbol as like a hungry alligator. Those are its teeth, and it's hungry for the bigger number. I know that's like probably something your 5th grade teachers taught you, but hey, it still tracks. So, all right, in number 2, we could read this literally as -7 is less than or equal to x, which is less than 0. I would just think of this as 0 is between x is between -7 and 0. It can include the -7, exclude the 0. So on my number line, if I put like a -7 and a 0, I do need both those numbers. I know that x could equal -7, but not 0. So close circle on one side, open on the other. And if it's helpful, you could break this in to like 2 different inequalities. So really this piece is telling us if -7 is less than or equal to x, x is greater than or equal to -7, and this we know means x is less than 0. So we only want to shade between these 2 numbers because this shaded part of our number line now represents every x value from and including -7 up to but excluding 0. All right, 23, real similar. From -15 to 8, I want an open circle on the -15, a closed circle on the 8, and then I want to shade everything that is in between because x can be greater than the -15 but less than or equal to the 8. All right, I think that concludes the Go.